Okay, so we have looked at sine and cosine and tangent and how to write ratios and solve for side lengths and all of that so far in the last two sections. In 9.6, we are solving for right triangles, which means we are finding any angles that are missing and any sides that are missing. So we will do that, the sides will do that just like how we did in sections 4 and 5 when we were asked to find a side in our right triangle with our trig functions. For the angles, missing angles, we kind of will have two different cases. We may have a right triangle where we're given one of the acute angles, in which case we can just say, okay, 180 minus the 90-degree angle minus that other angle is going to give me my last one. Or if we're only given the right angle and we have to find both of our acute angles, we will use inverse trig functions. So with our inverse trig functions, we are undoing our trig function so that we can solve for an angle measure. So these are on your calculator as well. Where your sine, cosine, and tangent are, you're just going to hit the second button first. So if you want sine inverse, you're just going to hit second of sine, and same with cosine and tangent, so that you have this inverse function. But basically, if we, let's say we had a right triangle with side lengths of 3, 4, and 5. And we wanted to find our two angle measures. So we'll call these acute angles X and Y. So it doesn't matter which two sides you use. It doesn't matter which trig function you use. For X, I'm going to just use sine. So from angle X, sine would be opposite over hypotenuse, or 3 over 5. So to undo my sine to get that angle X by itself, I'm going to do inverse sine. So I'm going to multiply everything by inverse sine. So that inverse sine is going to essentially cancel out my regular sine and just leave me with X. So X is going to equal inverse sine of 3 over 5. Now this is straight calculator. So again, you always want to make sure your calculator's in degree. Hopefully it already was if you'd already changed it. If not, on your calculator you're going to hit mode and you're going to arrow down to where it says radian and degree. And you want to make sure that degree is highlighted black. So if it's not, you're just going to arrow over to degree and hit enter, and then you'll be all set. So to put this in my calculator, you do second sine. That's going to give you that sine with the -1. And you're going to do 3 divided by 5 and close your parentheses. After that, you just hit enter. Usually, it's going to ask you to round to either the nearest degree or to the nearest tenth. So I'm just going to round to the nearest tenth here, which would give me about 36.9 degrees for X. Now, if you're finding both of the angles like this, you now have two options because you know two of them. So you could subtract the 90 degrees and the 36.9 degrees from 180 to find angle Y. But I'll go ahead and just set up another trig function. So if I'm going from Y, I'll just use tangent this time for a different one. So tangent of Y, opposite from Y would be 4, adjacent would be 3. Same thing. I want to multiply everything by that inverse tangent. That inverse tangent is going to cancel out my regular tangent. So we've got inverse tangent of 4/3. So in your calculator, second tangent, 4 divided by 3, hit enter, which to the nearest tenth is going to give you 53.1 degrees. So Cosine would be exactly the same type of process. So you're just matching up the sides that you have and using an appropriate trig function. If you have all three sides, it doesn't matter which trig function you use. I would encourage you to not use anything that you've had to round unless you absolutely have to. So I wouldn't use, like if we needed to find a triangle side that ended up being rounded to the nearest tenth, I wouldn't use that one to solve for an angle measure. I would use the two that you were given, things like that. Okay, so in number 1, determine which of the two acute angles has a cosine of 0.5. So 0.5 is obviously a decimal. If we were to write 0.5 as a fraction, it would be 1/2. So we need 1 to be the adjacent side and 2 to be the hypotenuse, because remember, cosine is adjacent over hypotenuse. So if 2 is our hypotenuse and 1 is our adjacent side, that means square root 3 would have to be the opposite side, which is going to leave us at angle B. So the cosine of angle B would be that 1/2 or 0.5. Okay, so 2, 3, and 4, it's just to give you a little bit of extra practice on how to type these into your calculator to solve for the angle measures. They want you to round to the nearest tenth of a degree, so that's 1 decimal place. So to undo tangent, we're multiplying everything by inverse tangent. So that inverse tangent is going to cancel out your regular tangent, and it's just going to leave us with angle G. And in your calculator, you're just going to type in your inverse tangent of 0.43. So second tangent, 0.43, which to the nearest tenth is going to give you about 23.3 degrees. And we're doing the same thing with that sine and cosine in 3 and 4. So I would encourage you to pause and try those two on your own, type them into your calculator, see what you can get, and then come back and compare it to what I have. So in number 3, we need to undo sine. So we're going to use the sine inverse, which is going to cancel out my regular sine. So sine inverse of 0.68 for angle H, which is going to give me about 42.8 degrees. And then in number 4, cosine of k equals 0.94. So I need to use cosine inverse to undo that cosine. And when I do cosine inverse of 0.94 in my calculator, I get about 19.9 degrees. So when you're asked to solve a right triangle, you're just finding anything unknown. Side lengths, angle measures, anything unknown. You can solve a right triangle when you have one of either of the following: 2 side lengths, or 1 side length and 1 acute angle measure. So as long as you have one of those 2 things, you can solve the triangle. So we're just solving our triangles in 5 and 6. We're going to round decimal answers to the nearest tenth, so 1 decimal place. So when you're given 2 side lengths, I tend to always find the third side first. So I'm going to call this missing side in number 5 F, because it's opposite of that angle F. So that's just Pythagorean theorem. We know our 2 legs. So 20 squared plus 21 squared is going to equal F squared. 20 squared is 400. 21 squared is 441. when I add those together, I get 841. And then 841 is a perfect square, which gives me 29 for that third side. And now I just have to find my two angle measures. So I'm given both of the legs. So I'm going to find angle E first. So from angle E, 20 is my opposite side, 21 is my adjacent side, which would use tangent. So the tangent of angle E is going to be 20 over 21. I'm going to use that inverse tangent to solve for angle E. So second tangent, 20 divided by 21 to the nearest tenth is going to give me 43.6 degrees. And then for my third angle, I already know two of them, so I know all three of those have to add to 180. So 180 minus 90 minus 43.6 is going to give me an angle measure of 46.4 degrees for angle D. So if you feel confident enough to try number 6 on your own, I would encourage you to do that. And then come back and hit play and compare your answer to mine. We're doing the same process that we did in number 5. I'm going to solve for my side, and then I'm going to solve for my two angles. So in number 6, 109 is my hypotenuse, 91 is a leg, so I have to solve for the other leg. So since that side is across from angle H, I'm just going to call that side H. So H squared plus 91 squared equals 109 squared. So 91 squared is 8281. 109 squared is 11,881. I'm going to subtract to get 3,600. And then when I take my square root, I end up with 60 for that third side. So I'm going to start with angle H. Doesn't matter which one you start with. From angle H, 91 is my adjacent side, 109 is my hypotenuse. So that's going to be cosine. So cosine of angle H is 91 over 109. I'm going to do my inverse cosine to solve for that angle. So second cosine in my calculator, 91 divided by 109 gives me about 33.4 degrees for angle H. So now for angle G, I know two of my angles, so I'm just going to subtract those from 180. So 180 minus 90 minus 33.4 is going to give me 56.6 for angle G. So in number 7, this is the other way that we can solve a right triangle when we have an angle measure and a side length. So we don't have enough to use Pythagorean theorem to solve those side lengths, so we have to use our trig functions. So we do have enough information to solve for our missing angle right away, because we know one angle is 92 degrees and the other one is 52. So we can find angle Y by subtracting those two angles that we know, which is going to give us 38 degrees for Y. And then I'm going to call this side X and this Z, since they're opposite angles X and angle Z. And I'm just going to start solving for those. So it doesn't matter which one I start with. So I'm going to use this 52-degree angle since that was given to me. So from that angle, x is opposite, 8.5 is adjacent, z is the hypotenuse. So if I want to solve for x first, opposite and adjacent, since I know the adjacent is going to be tangent. So the tangent of 52 degrees equals x over 8.5. Now we're not solving for an angle, so this is just like it would have been in 9.4. Okay, so to get x by itself, we're going to say 8.5 times the tangent of 52 degrees. So in my calculator, 8.5 times tangent 52, close my parentheses, which to the nearest tenth is going to give me about 10.9 for that side. And then for z, now remember we want to use the side we were given, not a rounded side. So I don't want to use that 10.9, I want to use that 8.5. So the 8.5 is my adjacent, z is my hypotenuse. So I want to use cosine of that 52-degree angle equals 8.5 over z. So we want to get z out of the denominator. So we're going to ultimately divide 8.5 and cosine of 52. Which to the nearest tenth is going to be about 13.8 for that third side. Okay, so in number 8, we aren't solving for every missing piece. We're just solving for an angle x. So it says your school is building a racked stage. The stage will be 30 feet long from front to back with a total rise of 2 feet. You want the rake or angle of elevation to be 5 degrees or less for safety. Is it within your desired range? So we just have to say, okay, is x between 0 and 5 degrees? If it is, that's what we want. If it's more than 5 degrees, it's not going to work. So we know that the stage is 30 feet long and that at the back of the stage it has a height of 2 feet. So from angle x, that height of 2 feet would be the opposite side. Our 30 feet is opposite that right angle, so it's going to be our hypotenuse. So opposite over hypotenuse has to be sine. So the sine of that angle x has to equal 2 over 30. Now 2 over 30 simplifies. Simplify it if you want, don't simplify it if you don't want. That makes no difference at all because we're just using it in our calculator. So to get that angle x by itself, we're going to do the inverse sine. So in our calculator, second of sine, 2 divided by 30, close those parentheses. And to the nearest tenth, we've got about 3.8 degrees. So is that within your desired range? Yes. It's less than 5 degrees. Okay, so that is 9.6. If you need me, email me, join the Zoom call, request a Google Meet, whatever you need to get a hold of me is fine. Your homework will be ready to go on the Big Ideas Big Ideas website, sorry. So get started on that and let me know if you have any questions.